All right, so here we go. So we're on page 17, and what we're going to do is start doing inference with means with two means. So you've just finished one mean, and you did those by hand. When I start mixing in two means, then I let you use the calculator. So we're going to get to do these two means in the calculator. All right, so let's move on. Let's actually just start practicing this. So here we go. A dietitian has developed a diet that is low in fats, carbohydrates, and cholesterol. Although the diet was initially intended to be used by people with heart disease, the dietitian wishes to examine the effects of this diet has on weights of obese people. Two random samples of 100 are randomly selected. The one group of 100 is placed on the low-fat diet, and the other group of 100 is placed on approximately the same quantity of food, but is not as low in fats, carbs, and cholesterol. Each person, the amount of weight loss or gained in a 3-week period is recorded, and the results are below. All right, so we have two groups, and these groups, what are we talking about for these groups? What are we talking about? The weight loss. Okay, good. What are the two kinds of groups that we have?
The ones on the low-fat diet.
Good. And then the one on the other. Good. So let's define it. Mu of L equals the average weight loss of obese people on the low-fat diet. So we're going to make a generic claim about all obese, average weight loss of all obese people that are on the low-fat diet. And then mu with the little o is going to be the average weight loss. I'm just going to ditto marks of all obese people on the other diet. All right, so we have two groups. All right, so our null hypothesis is going to be what about the weight loss of those two groups, the average? Good. So we are going to start off saying, okay, you guys have the same average weight loss, but then prove it to me that they are, let's see, what do they wonder? They wish to examine the effects. So do we say one way or the other? They just want to imagine.
That they're different?
Yeah, it sounds like they're not speculating as to how that is. They just want to examine the effects that this diet has. So that's the just not equal to. It doesn't say to see if one is more or less than the other. All right, so the alternative is going to be that mu of L is not equal to mu of the other diet. Okay, so we get to use our calculator on these. So let's go to our calculator. So let's open it up, and I'll show you where everything is and where we're going to put everything in there. We're going to do stat over to tests. Okay, so stat over to tests, and we are going to do the number 4, which is 2 sample t test. Okay, so you might want to make yourself a note. We are going to be doing a 2 sample t test. And we do t test because we just have a sample standard deviation. Okay, so I'm going to go down here. Number 4, 2 sample t test. Now, I want to explain these two little things up here. One option is to do data, and one option is to do stats. If I do data, that would happen if you had a whole list of data and you put one list of data in list 1 and another list of data in list 2. So you would use the input as data if you had lists of data. Let me give you an example. You will be doing one on your assignment. It'll look like this. In this case, you would put your list in list 1 and list 2, and you would use the data part on your calculator. Okay, But we do not have that. What we have given to us is actual number values that are already computed, so it gives us statistics. So it gives us actual sample statistics, so that's why it looks on our calculator as stats. We're on the thing that says stats, okay? What does X bar 1 mean? The sample mean for the first group. Which one do you want to call the first group, by the way? Okay, so this information here is going to be my low fat, and then this information here is going to be my other. Okay, so I can see what I'm going to put in my calculator is, so the low fat has a sample mean of 9.3, sample standard deviation of 4.73, and a sample size of 100. I got that information right here, and then the 100 I got from the paragraph. Okay, and then the other diet, 7.4 is the mean. 4.03 is the standard deviation, and it also told me that this, up in the paragraph, that sample size is 100. Okay, so I want you to type those things into your calculator right now. I'm in stat over to tests, 2 sample t test. 2 sample t test. Oops, I'm on the wrong place. It's not doing. Yep, not equal to. And then it's going to ask us about pooling. And here's what you think about. You don't ever want to see Miss McClellan out at the pool. So we will never pool. Okay, so no pooling. No pooling. Ever. What? So we're never going to pool. You're never going to go pool with Miss McClellan. Never going to go pooling.
I know what I calculate or draw.
You want to calculate?
I didn't know what draw was.
You always calculate?
Yes.
I just didn't know what draw was.
Draw will draw a normal curve for you.
Okay.
So not equal to. So see that section that says pooled no or yes? Always leave it on no. And then you can calculate or you can draw, and we just always calculate. So our t-score, okay, so we got a t-score of 3.058, 2 significant digits, okay, and then a p-value of 0.0025. Okay, if you didn't get that, then you plugged in your numbers wrong into the menu. Okay, now this is interesting. Did I not leave a space for degrees of freedom? You actually do need to write down what the degrees of freedom are, and it's 100 because it's special for 193.13. It's some other funky formula which we don't have to compute, and we don't ever have to know how to compute, so we're not ever going to compute, but we will just write it down. Okay, it's not a simple n-1 or n-2.
So on the t-score and the p-value, are you going to 2 decimal places? Oh,
2 significant digits. 2 significant digits. All right, so I'm going to compare my p-value to alpha. So I'm going to say that my p-value, which is 0.0025, is less than, did it tell me my significance level?
No.
Okay, it did not. So therefore, it's 0.05. So it's less than. So what are we going to do if it's less than?
Reject.
We will reject HO. So what's my decision?
There is evidence.
There is evidence that, and you could write this out in words on the test or the quiz, but we can shortcut it for now, that the mu of L is not equal to the mu of O. That's the alternative.
So we can't do that on this?
Not on test or quiz. On test or quiz, you have to write it out. So on the test or quiz, you would say, there is evidence that the average weight loss of all of the low-fat diet is not equal to the average weight loss on all of the other diet. Okay, I think you could write out what the symbols mean. Okay, now the rest of the class period you're going to practice, but let's have a discussion before you do that, because I'm actually going to start now throwing at you one, this practice, first of all, is going to be a mixture of one or two means. So you're going to have to read it and know if it's one or two. But the good thing is that even if it's a one, I'm going to let you use the calculator on it. So let's take a look at this first one and let's read through it, and then I want you to decide if it's a one sample or two samples. Is it talking about one mean or two means? So here we go. The Environmental Protection Agency estimated that the 1991 G car obtains an average of 35 miles per gallon on the highway. And the company that manufactures this car claims that that is incorrect. To support its assertion, the company randomly selects 36, that's in words, so you might miss that if you don't notice that. What is that? Randomly selected 36 cars. That's going to be the sample size. Randomly selected 36 cars, and records the mileage obtained for each car over a driving course similar to that used by the EPA. The company found a mean of 36.8 miles per gallon with a standard deviation of 6 miles per gallon. Does the data provide sufficient evidence to support the manufacturer's claim that the average miles per gallon is different from 35? Use 5% significant level, so that means alpha is 0.05. Oh, okay. All right. So what do you think? Do we have one mean or two? So did you decide if this was one mean or two means? One. It is one. It is the mu is the average, what? Miles per gallon of all of these 1991 G cars. Okay. Let's see. Our null hypothesis is the claim. And what do they claim?
35 miles per gallon.
Okay. The EPA says it's 35 miles per gallon. And the company that makes them says that it's not. They said that it's incorrect or that it's different. So what kind of sign do I have?
Not equal to.
Okay, mu is not equal to 35. I wish that problem was worded differently, because probably the company is offended by them saying it's 35. They're probably going to say it's actually what? More than. Greater miles per gallon. Hey, we make good cars. It's probably more than 35 miles per gallon. But anyway, so I'm going to let you use your calculator. And so I'm doing this to teach you that your calculator for a one sample, in the calculator it just says t-test. It does not write the words one sample t-test. So let's go there in our calculator. Stat over two tests, and do you see number 2 is a t-test. That's the one we're going to use for one sample mean. All right, it is statistics. What is this mu, the claimed mu? Good, the claimed mu is 35, but they took a sample and the sample results that they got were 36.8. So that's X bar is the sample results with a standard deviation of 6. What is the sample size? How many cars did they do this on? 36.
Wait, where'd you get 6?
Okay, so this is N, and then this is the standard deviation. This is the sample mean. Okay, so that was our X bar, that was our S of X, and this is our N. Okay, so then we're going to use the tail of not equal to, and so let's go ahead and type in those things here. It says 36 in words, so we're not equaling. T equals 1.8, and the p-value 0.08. So we're going to compare our p-value. Oh, yes, ma'am. Thank you very much. Good job. We do need the DF always, which it doesn't give it to us. So, oh, wow. But what do we know the degrees of freedom is for it's just one sample, so it's the simple n minus 1. So it's that n minus 1, which is 35. That's why they don't give it to you, because that is a simple one that you can calculate. So what do you have to say about a p-value of 0.08? It is greater than alpha of 0.05. So we will fail to reject HO. So do we have evidence that of it's not equal to? No, we do not have evidence. So we do not have evidence that the average miles per gallon of all 1991 G cars is different than 35. So we don't have evidence to say that EPA is wrong. Okay, so I have done one of the 2 samples for you. I have done one of the 1 samples for you, and you get to use your calculator now. So it is all up to you. Read and decide if it's 1 or 2 sample and finish it up. You got 4 more to do.